Today's going to be 31.9. We're going to take a look at the unit circle again, and we're going to look at sine and cosine inverse ratios. So we're going to utilize the unit circle to find the angle of common ratios. Now, just a reminder, if I wanted to find the angle of a trig ratio, you're going to use the idea of an inverse. So if I had sine of theta equals 5, 6, you would have to take the sine inverse to both sides. And so theta would equal sine inverse of 5 over 6. And if I entered that in my calculator, I could get this approximation of 56.44 degrees. Now we can use that same analysis when we're trying to find the angles on the unit circle. So for example, on this first one here, if I wanted to find what theta is, right, because it says find all the angles that satisfy the equation, taking the sine inverse to both sides, theta equals the sine inverse of 1/2. Now using the unit circle, this is saying what angle does sine give me 1/2. So I need to look at my sine values, which are my y, and I need to look at the ones that are 1/2. So this one's 1/2, so that's 30 degrees. And then keep going. This one's 1/2, so it's 150 degrees. So my answer is going to be 150 degrees and 30 degrees. Cosine of theta equals negative root 3 over 2. So if I take the cosine inverse to both sides, theta is going to equal cosine inverse of negative radical 3 over 2. And so here it's saying what angle is my cosine going to be negative radical 3 over 2. And so that's going to be here, and that's going to be here, because my cosines are my x values, and so that's going to be 5 pi 6 and 7 pi 6. Now you're probably wondering, wait, why didn't the other one did I use angles and this one I used degrees? Sorry, the other one I used degrees and this one I used radians. The reason being is because technically the phrasing is so ambiguous I could use either. Now the way that we know if I need to use angles or degrees is based on this notation. If it says theta is between 0 degrees and 360 degrees, that means that I have to have my units in degrees. If it says between 0 and 2 pi, then my unit needs to be in radians. Where is my sine going to be 1? So where's my y value 1? And so here, so I can say that theta is going to equal 90 degrees. Where's my cosine theta going to be negative 1/2? So taking the cosine inverse to both sides, theta equals cosine inverse of negative 1/2. So looking on the unit circle, where is my cosine going to, what angle gives me my cosine to be negative 1/2? Well, it's negative 1/2 here and here. So it's going to be 2 pi thirds and 4 pi thirds. And that will be my answer. Where is my sine of theta negative 1? So looking at my y, well, it's positive 1 here, it's negative 1 here. So theta is going to equal 3 pi halves. Let's look at one more. Where is my cosine going to be 0? Well, my cosine's 0, well, it's 1 here. It's going to be 0 here, so this is one of them. Negative 1 and 0 here, so this is the second one. So theta would equal, so theta equals cosine inverse of 0, which now equals pi halves and 3 pi halves. To close today's lesson, what did we learn today? Well, once again, we examined the unit circle, but this time we kind of thought backwards. What we engaged was, how do I find the angles given a ratio? So we were looking at what are the measurements of rotation if I have the particular trig ratio. So now I want to hear from you guys. So what does the inverse trig function represent? And sine relates to which coordinate? Because I kind of forgot. Please memorize the unit circle. It's important. This does conclude our lesson. If you have any other questions, please leave them in the comments.